eating some food before. SWT. Hi. How are you? Having a fun Friday? It's super windy. I love when it's really windy. A nice cool breeze. Yeah. I actually like when I don't like when it's that hot. Like I don't like when it's like 70 or 80. I like a nice cool breeze. Let me all right. Welcome everybody. Welcome Ashley. Good to see you again. Welcome Kryptov. You again. We're gonna start in a few minutes when start to roll in. Welcome snowmobiles. Good to see you. Snowmobiles, what are you gonna be up to this weekend? You too, SWT. What's everyone got planned? Ashley, anything fun? Yeah, you can, Surrey Cat. You can keep building. Surrey Cat's on the Minecraft server right now. Just rest. Yeah. Yeah, so if you want to, I'm gonna be live streaming the event on YouTube. So if you don't want to load in, you can totally just like go to the live stream. But if you want to participate, you should totally join in. But yeah, get some rest. Been working hard. Welcome, generous kid. Good to see you. SWT said concert. What concert you going to? Harry Styles? Hey, generous kid. I'm gonna guess that SWT is going to Harry Styles concert. So I guess that's a no. All right. Yeah, in 2 weeks, I'm actually gonna go to a Billy Joel concert. I'm so excited about that. Eric Nam. Never heard of him. Eric Nam. Oh, look at that. Wow, he's good looking. Good looking dude. There he is, Eric Nam. Look at his style. He's dress is nice. There he is. Is he a big K-pop? Big K-pop star? Oh yeah, okay. Or Coop. Is that, did you mean to say K-pop or is that a different, I don't know what Coop is. Oh, K-pop. Oh, okay. Yeah. Awesome. All right. So we can get started. Yeah, welcome everyone. This is workshop 6 out of the 8. On Wednesday's workshop, we went over chapter 4, days 1 and 2, which was talking about account storage. So we're going to take everything we've learned so far and start creating our own NFT contract, which is super exciting. And we actually, last time, we started coding up the contract and we named it Baby Jacob. So I don't remember who suggested that, but whoever you did, you're funny. And yeah, so here we are. Cool. So we have our Baby Jacob NFT. I can't believe we have to say that over and over again, but we have our Baby Jacob NFT contract. And yeah, so let's keep going here. So actually, I guess let's just review what we have so far, right? So we have a total supply. So this is the total number of NFTs in existence. We have our NFT, which represents NFT, obviously, right? And then here it has a unique ID. And we set that ID to be self.uuid. Oh, it's like C#. Nice. Yeah, it's like similar to Swift and C#. Oh, and welcome, Lil, actually. Good to have you here. So inside of our NFT, we set, the ID to be self.uuid, right? And the reason that this is so cool is because, like we said before, every single NFT should have a different ID, right? Or then if it doesn't, then it's a fungible token, right? But this is a non-fungible token. So we set the ID to be self.uuid, which is really helpful because UUID is always different for every single resource. So we know the ID will always be different for every NFT that we create. Awesome. So then what we did was inside of our, inside of our transaction, what we decided was that instead of storing a single NFT to our storage, we were going to store a collection of NFTs to our storage. And that's really helpful because that allows us to only have to store one thing in our storage, but it's almost like a folder, and it's a folder of NFTs. So we created the collection resource, and inside the collection resource, we put an owned NFTs dictionary that just has a bunch of NFTs inside of it, right? And then other than that, we just added a deposit function to deposit NFTs to this dictionary. We added this destroy function because we went over that in order to, when you have resources inside of resources, you need to have a destroy function, right? So then you specify destroy the owned NFTs if this gets destroyed. Then we added a create empty NFT collection, and we added a create NFT public function, right? So awesome. Hopefully everyone is good with this so far, and we can keep going with the lesson. So I think we got all the way down to here, which was collections. And we started talking about depositing, withdrawing, all this fun stuff, right? All right, cool. So let's go to our playground. And let's add some functions to our collection. So, and also, by the way, we will test these functions as well in a bit. Okay. So we have this deposit function which deposits a token, which we're calling, which is just a token variable, and that's a non-fungible token resource. And then we say self.owned NFTs at token.id, which is a UN64, right? And we're mapping a UN64 to the token itself. Now, some of you may be wondering, why can't we just move it like this, right? Why can't we just move the token in? And the reason is because we sort of talked about this before. But you know, when you're moving a resource into a dictionary or array, you have two options. Either you do it like this way, right? You say you do it like the double move way, and then you destroy old token, right? So you can do the double move, or you can do the more simple one, which is you put the force move operator right there, and then it's okay. Okay. Awesome. So that's deposit. Now we can go over withdrawing. So what if we want to withdraw an NFT from this collection? Well, we can say public function withdraw the withdraw ID. So what's the ID of the NFT that we want to withdraw? And then we can return an NFT resource. Okay, awesome. So let's say let NFT, we're gonna move it out of self dot own NFTs dot remove, and the key that we want to remove is withdraw ID, right? And then we can return the NFT. Now notice it's saying mismatch types expected babyjacob.nft and got babyjacob.nft question mark. So that's because this is an optional. So we can say if we go to remove it and it doesn't exist, let's panic and say this NFT doesn't exist here. Awesome. Cool. So this is just, you know, we went over this in in the previous lessons when we talked about how to withdraw and deposit from a dictionary. Remember, we were talking about that in I believe it was chapter 3. So this is exactly what we're doing, just inside of a collection resource. Okay, awesome. Now let's add one more function called get IDs, and get IDs is going to return an array of UN64s. And this is just going to be a function that returns all of the different NFTs that are in this dictionary here that we own. So we can just return an array of UN64s. So let's return self.owned NFTs.keys. So this will return all of the keys inside the owned NFTs dictionary. So this allows us to deposit, just like a recap, deposit an NFT. This allows us to withdraw an NFT based on its ID. And this returns a list of all the IDs, all the NFT IDs that we own. Yay! Super cool. Let's go ahead and deploy this contract. And boom, we've deployed it. Yay! So we just did this part, which is deposit, withdraw, and then get IDs. And then the next step was to go inside of a transaction and to actually, you know, like actually deposit to it, right? So that's what we're going to be doing in this next example. Okay, awesome. So how's everyone doing? Is everyone good so far? Cool. Let's go ahead and deploy this contract. All right, awesome. So let's go to a transaction here. And we can, yeah, so we right now we're saving a collection to our storage, which is pretty cool. So why don't we do this? Why don't we let's get rid of this for now. We'll use this in a second. Can I do that? Oh no, I just have to do this. Okay. Oh shoot. Okay. So let's comment this out for a second. So let's go down here. And also this transaction is going to say I saved a collection to my storage. So we're going to say signer.save. Actually, I'm trying to think of the best way to do this. Yeah, actually, okay, I'm going to do it this way. Sorry. Okay, I'm going to do it this way. So I'm going to save the empty collection, right, to our account storage here. And remember, this babyjacob.create empty collection, this is returning a collection. That's this function right here. So it's returning a new collection for us, okay? So we can say this transaction is now going to be setup collection, or we can call it save collection. All right. So in here, we're going to do signer.save the empty collection to /storage/NFT collection. And let's do that now. So let's send this. Awesome. So what this is going to do is this is going to allow account 1, because we ran it from account 1, it's going to let this account now receive NFTs. So sort of a fun fact, if you ever have gone on like a website, right, like an NFT drop for Flow, or you go on like any mainnet platform, where you need to like, it's like an NFT project. Usually when you go to their webpage, they have you sign a transaction. And that transaction is exactly what this is doing. It's setting up your account in order to receive NFTs from them. So that's usually why you have to run like a setup transaction on people's websites. Just if you were curious. Okay, so we saved the collection. Yay. Now what we can do is we can link collection. All right. So in this transaction, we're going to link our collection to the public so that anyone can read from it. Now, here's the problem. Right now, if we look at our collection, we have a deposit function, a withdraw function, and a get IDs function. So does anyone want to make any guesses? Would it be fine? Actually, I'll do this really quickly. Would it be fine if I did something like this? If I linked this and said NFT, so /public/NFT collection, and did that for storage as well. So if I linked the collection at this path to the public and linked it with this type, does anyone have any guesses on why this might be a problem? Why might it be bad that we're linking this type to the public? Exactly, Alfredo, exactly. So the problem with doing this is that now that it's in the public domain, anyone can get a reference to babyjacob.collection and call the withdraw function, right? That's really bad. And I'll show you an example of this right now. So we link this to the public, so we can send this, and it says I linked the collection to my public path. And then let's go down here and say like borrow collection, right? So then let's copy and paste the transaction code, go to borrow collection. And in here, we can say let collection equals, and we're going to run this from a different account. So we can, so we're going to take in an address, which is an address. And we're going to say let collection equals get account, the address, which is going to be account 1, right, that we just linked it from. Let me refresh the page so we get the auto complete. Get capability. We linked it to /public/NFT collection. And then we're going to .borrow the reference to babyjacob.collection. And remember, this is all because that's the type that we linked right here, babyjacob.collection, a reference to it. And it's from the public/NFT collection, which is why we did public/NFT collection. And then we're going to panic if it doesn't exist. So an NFT collection doesn't exist here, although we know it does. All right. And then we can say collection. I got to refresh. So collection dot withdraw. Uh-oh. It's allowing us to withdraw. See that? And then we could destroy it if we wanted to. And that's really bad. See what I mean? Because right now, if we wanted to, we could type in account 1 and we could sign this from account 2. And this would work. It would allow you to withdraw because we linked the full reference to the collection to the public. And that's really bad. So we sort of went over this problem in during workshop number 5 on Wednesday, where we talked about there's something that can help us here to only expose certain functions. Does anyone remember what that is? And maybe how we can do that here? Or I guess starting in the contract? I know Ashley's got the answer. Super excited. Interfaces, exactly, Ashley, exactly. So we can use an interface to only expose certain things. So let's go to here and do public resource interface, collection public. Boom. And in here, what do we want to include here? We definitely want to include get IDs, right? Because that's harmless, right? Who cares about exposing that to the public? The public function get IDs, and this returns an array of UN64. And what is something else maybe that we want to include in here? Right? Like, why not just depositing, right? Like, who cares if people give us NFTs, right? I want NFTs. So we can put that in here as well. So boom. We also put deposit in there. Yay. So, and then we forgot one thing. We have to link this, or we have to implement this on the resource itself, right? So if we do this now, if we redeploy the contract, we save the collection. So let's save the collection to account 1. Awesome. Now let's link it. But the difference here is that we're only going to link babyjacob.collection restricted to babyjacob.collection public. And now, if I refresh again, now the public will only be able to call the functions that are in this collection public, which is deposit and get IDs. So let's run this transaction. Boom, I linked the collection to my public path. Awesome. Now we can go to borrow collection, and let's see if this works now. So if we try and refresh this page, you know, it's not going to give us errors right now, but if we try to run this transaction from like account 2, for example, an NFT collection doesn't exist here. And that's because we put in the wrong type. So it's panicking right here, right? So if we were to put in the right type, which would be baby jacob.collection public, right? Then if we were to put that there, then it's going to say, wait a minute, member of restricted type is not accessible, withdraw. So we can no longer withdraw. Cool. Does that make sense to everybody? Why we're doing that? Because we don't want people to withdraw from our collection. All right, we all good? Cool. So we know that this is never going to work, so we can just get rid of this for now. We can just change this to I borrowed collection. Okay. So let's do some more exciting stuff. So let's go ahead and run a function here, or run a script here called get IDs. And this is going to get all of the IDs inside of our collection. So we know that in order to do that, we have a get IDs function right here that returns an array of UN64s. And anyone can call this because it's in the collection public, and we link collection public to the public right here. So inside of our script, we can actually do this totally fine. We can say let collection. And for the record, this is going to be the exact same thing as this, like literally copy paste, but I'm just going to type it out again because I think it's helpful. Equals. Let's get rid of the return type for a second. Actually, you know what? We know that we're going to be returning an array of UN64. So let's just like return an empty array for now, and it'll stop giving us errors, right? So let collection equals, we can pass in an account address and say get account, the account, get capability / public / NFT collection, right? Because that's where we linked it right here, / public / NFT collection. And then we can go in here and go to get IDs and say, okay, dot borrow. Boom. We're borrowing a reference to baby jacob.collection, restricted to baby jacob.collection public. All right. And then panic, if it doesn't exist, say a collection does not exist here. Awesome. And then I don't know why it's giving us a bunch of problems, but that should be fine. What's going on? Should be fine. Although it's not giving us weird problems. Huh. Okay, maybe we just keep going. And then return collection.get. Wait, what? What's the problem here? Did anyone spot it? I think it might just be the playground being really annoying. I don't see a... Oh. I forgot to put the 2 parentheses here. So we have to put the 2 parentheses there. Yep, exactly. Okay, boom. All right. So then we can return collection.get IDs. And look, so even if we type in dot here, it'll tell us all the functions we can run here. Now, it's showing withdraw, but if we do withdraw, it's going to say, like, it's not accessible. But what are some other ones we can do? Like, get IDs, for example. Boom, get IDs. Yay! And now it works. So if we type in account OX01 here, it's going to execute, and it's going to be an empty array, because we don't have any NFTs inside of our collection, right? But if we type in, it's almost like this is like a mini quiz. What do you guys think is gonna happen if I type in 0x02 here, and why? Like, why will that happen? So this works if I type in 0x01, it's gonna return an empty array because we don't have any IDs. But if I type in 0x02 here or any other account, why is it gonna be a problem? Any takers? I believe in you, Snowmobile. Said, no, you got it. Contract in there? Close, close. I think you meant collection. So yeah, so the reason is because when we go to save, like, when we do account 1, the reason this works is because the collection is actually at this path, right? We saved it to account 1, we then linked it from account 1, and then we got the IDs from account 1. But if we try to do this with account 2, it's not going to work. It's going to say, and a collection does not exist here, and that's because we never actually gave a collection to account 2, right? Account 2 never signed this transaction to give themselves a collection. So if we were to give them a collection, we then linked it. Then if we went to get IDs and typed in 0x02, boom, it's gonna work now. All right, awesome. So it's just sort of like solidifying that idea that these accounts must have like them set up already in order for these to work. Alrighty. So that's all awesome. Now let's actually run through an example of giving someone an NFT inside their collection. So right now in account 1, we already saved the collection and we already linked it. But let's go ahead and mint. Let's call it mint NFT to somebody. All right. So what we can do is we can take in an address for who we want to mint it to. All right. And we can get their collection right here. We already did that, right? So let collection equals get the address, get the capability, borrow it, panic, right? It's a lot for sure. But look, so it's already here. So what we can do now is we can say, well, first of all, let's mint the NFT. So and let NFT equal baby Jacob dot what do we call it? I think we called it create NFT, right? This returns an NFT resource. So we can let me refresh. We can do baby Jacob dot create NFT. Awesome. And then it's this loss of resource. So why don't we actually deposit it to the collection? So let's do collection dot deposit, and you have to pass in the token argument and the token. So let's move in the NFT. Right? Boom. There we go. So who do we want to deposit this to? Well, we can only deposit it to people who are actually set up. So again, if we try and type in like account 5 here, and also, by the way, it doesn't matter who's signing it right now. It doesn't matter. Actually, I wonder, can I delete this? Oh, I think I can. Yeah, so we don't even need anyone to sign this, right? Because this is just all public stuff. Because we're allowing anyone to deposit an NFT, right? Yeah. So does anyone know? Actually, I already asked this question, but like, just to solidify the point, this won't work, right? If we send this, an NFT collection doesn't exist. And this is exactly why, again, that when you go to those websites, right? You go to Versus, you go to Matrix World, you go to Goats, you go to Zeeds, you go to whatever project you want. The reason that you always end up signing like a setup transaction is so that you can give someone this collection so that when they go to mint you an NFT, they can borrow it from the public path. Because obviously, if you don't have a collection yet, then they won't be able to borrow this public path and give you your NFT. So that's sort of like a cool thing I just wanted to point out. So if we go ahead and send this, although I think we actually do need this. Yeah, I think it's going to be weird if we don't. So let's go ahead and type in account 1 here, and we can send it from anyone because it doesn't matter. Click send, and this should say I minted an NFT to the collection. But anyway, we minted an NFT now, right? Because this had printed. So boom, that's all good. Now, if we go to get IDs, we actually should see that account 1 has some IDs in its collection now. Look at that, boom. So the value, which is just this return value, is a array of UN64s, and the value is 2. Yay! So we have we have an NFT with ID 2 inside of this right here. And if we were to mint them a lot more, let's just keep let's just keep minting. So let's go to account 1 and let's just mint them a lot. Boom, we minted right now. Let's mint again. Let's mint again. So if we go to their IDs now and we type in account 1 and click execute, look at all the NFTs in their collection now. So 5, 3, 2, and 4. Make sense? Everyone good? Hopefully we're all good. Okay. So we just went over how to use deposit and get IDs. Let's talk about how to use the withdraw. So the withdraw, obviously, we can't use with the public path because that's not allowed because it's restricted to collection public, and collection public doesn't have withdraw inside of it. So well, we can do another transaction called destroy NFT. And this will allow a user to withdraw an NFT from their collection and destroy it. So let's do that now. Okay. So let's go to my friend just sent me something funny. Okay, so let's go to destroy NFT. We're not going to take in we're going to take in one parameter, which is the withdraw ID, and that's going to be a UN64. And none of this now. And let's just get rid of all this. Okay, and let's just say I destroyed an NFT that was in my collection. All right, so let's go ahead and get the collection. Now, should we get the collection from our storage path or our public path, and why? If we want to withdraw. So we want to withdraw. Any guesses? It actually is storage. Yes, it is storage. And the reason that it's storage is because if it was in the public path, first of all, that wouldn't really make any sense, because if it was in the public path, that would mean that anyone could withdraw from our collection. So that's not good. So it has to be from storage path, or at least it should be from storage path, because if it wasn't, that would mean that we had a huge security leak in our contract. So yes, we do want storage. So let collection equals signer. I hope they fix this playground bug soon. Signer dot borrow. Right, we're gonna borrow the reference to a baby Jacob.collection from, and then what's the from path? So where do we save it to? We saved it to /storage/NFT collection. So that's where we're gonna get it from. And then if this borrow doesn't work, we're gonna panic, say, heyo, an NFT collection does not exist here. All right. Then we're going to say let NFT the collection dot withdraw, and then the withdraw ID is the withdraw ID that we pass in right here, right? Then we can destroy NFT. Super cool. So if we refresh this page, let's first look at all the IDs that we have. So if we type in account 1 here and click execute, we have 5, 3, 2, and 4. So let's delete 4, right? Let's just delete 4. So let's destroy the NFT, and let's do withdraw ID 4. Send. I destroyed an NFT that was in my collection, and if we go to the IDs now and type in account 1, we will see that we now have 5, 3, and 2. So 4 got deleted. That's because we destroyed our NFT. So this allows the owner to get a, reference to the collection, withdraw, and then destroy. Alrighty. So I believe that was the end of this day. Okay. If an NFT is destroyed, do they re-release that UUID for the resource? That is a great question, Snowmobiles. I believe the answer is no, they don't. But let's look at it together. Actually, it should be in the doc somewhere. So if we go to UUID, here. So resources have an implicit unique identifier associated with them, implemented by a pre-declared public field. This identifier will be automatically set when the resource is created before the resource's initializer is called. The identifier can be used in the initializer and will be unique even after the resource is destroyed. Oh, look at that. There's the answer to your question. Will be unique even after the resource is destroyed. No two resources will ever have the same identifier. Very interesting, right? Yeah. All right. Cool. So we went over saving, linking, minting, and destroying. And for the record, by the way, usually in your transactions, this step, the linking step, will always be in the same step as saving. So we can move the linking here and delete the linking transaction. Because when you save your collection, you almost always want to link, certain public aspects of it to the public. So we can combine these two and just call this like setup collection. So we can rename this to setup collection. Right. So for this next part, we're going to talk about transferring. So let's open up a new transaction called transfer NFT. So we're going to transfer an NFT from one person to another person. All right. So let's copy and paste some stuff. We can use a lot of this as helpful code. I transferred NFT to recipient. So what we're going to do in this transaction is we're going to transfer an NFT from one person to another person. So in order to do that, we need to have a signer, and the signer is the person who is transferring the NFT, and then we will have a recipient. So the recipient is the person receiving the NFT, and then we'll also have a withdraw ID. Withdraw ID is the NFT being transferred. So we'll also have a withdraw ID here to transfer. So this is basically, yeah, so you will see this in a second. So it's kind of combining concepts from mint and destroy. So to transfer, we first of all need to we can comment this out for a bit. So let's just like put this down here for a second. So we first need to get the collection of the signer. So because we need to withdraw from their collection, right? Because we're withdrawing from them to the recipient. So let's say let signer collection equals signer dot comment all this out. Signer dot borrow from /storage /NFT collection. We're borrowing a baby Jacob dot collection type, right? And again, if this doesn't exist, we'll just say panic and NFT collection doesn't exist here, right? And then we can just say let NFT be a signer collection dot withdraw the withdraw ID. All right, so now we have the NFT here, and then this is where this comes back into play. So we say let recipient collection get the account from the recipient, right, that we pass in up here, and then get the capability, borrow it from the public path, and then panic if it's not there. And then on this public collection, we can do recipient collection dot deposit and pass in the NFT that we withdrawed right here. So do these steps make sense to everybody? We first of all get the signers collection. So we get the signers collection to withdraw an NFT. Then we withdraw an NFT from the signer's collection. Then we deposit, or then we get the recipient's public collection, because we have to get it from the public, right? Because we don't have their signature, so we can't get it from their storage path, and we shouldn't be able to anyway. Then we deposit the NFT to the recipient's collection. Alrighty. How's everyone doing? Feeling good? Feeling spicy? All right. So let's go back down to get IDs. And let's look at the IDs of some of these accounts. So account 1, we already set up. And it has 5, 3, and 2. What about account 2? Account 2 has nothing, right? So let's transfer 5 from this person to this person, okay? So let's go to transfer. Let's refresh the page. And recipient is going to be account 2. The withdraw ID is going to be 5. And we're going to sign it from account 1. So this person's the one transferring. So let's send this transaction. This I transferred an NFT to the recipient. Let's go to get IDs. And let's get the IDs of account 1 now. Boom, there's no 5. And if you go to account 2, boom, there's 5. How we doing? Doing all right? Hope everyone's doing okay. I hate if I lost you all. You have a few more things to go over, and then that should be. And for the record, we are like almost like 50% of the way there of being done now. I just want to make sure that I'm covering everything I need to, because we do have to move on to chapter 5 next week. Hi, Siri Cat. So, Ash, snowmobiles, generous kid, Will Ashley, Ukandora, we all good? Transferring's good? All right. So, if we're all good with that, let's go on to the last 2 things we have to talk about today. So, we'll take time to absorb. Yeah, that totally makes sense. Hopefully these recordings will be helpful for you, like when you actually get to the topic, so that you can go back and listen to me talk about it. Ashley, you're hanging in there. Yeah, it's definitely a hard topic. But we do have 2 more things to talk about today. And then we should be good to go. So, one problem with this contract right now, right? It's pretty cool. But one problem is that we allow anyone to create an NFT. That is definitely not good, right? We don't want everyone to be able to create an NFT. We only want like some sort of admin to be able to create an NFT. You can see that even in the mint NFT transaction, anyone can sign this transaction and just mint an NFT and just deposit it to themselves. And that's definitely not what we want to do. So what we're going to do is we're going to wrap this function inside of a minter resource. So public resource. Actually, what do I name it in the chapter? I want to make sure I stay consistent. I think I name it minter, right? Yeah, minter. Okay. So public resource minter. And we're going to put this function inside of that minter resource. Right? So now no one can call this function right now. The only people that can call it are the people that own the minter resource. But we're not creating the minter resource anywhere. So what are we supposed to do? Well, what we can do is inside of the contracts init function, and this is like probably the most common admin pattern. Inside the contracts init function, we can save a minter resource to account storage in here. So this is really interesting because so far we've only talked about how to store something to your account storage inside of a transaction, but you can also store something to account storage inside the init function of a contract. And what that will do is it'll save it to the account storage of the person that's deploying it. So this is really helpful for admin stuff because what this means is we can do something in here. Like we can self.account.save, and it's always self.account.save. The value, we can pass in a Minter resource and save it to /storage/NFT Minter. And what this will do is this will store a admin resource to account 1. And then only account 1 will ever be able to access this Minter resource, which is really helpful for us. So if we redeploy this contract, we can set up our collection, right? And then when we go to mint an NFT, this is a problem now because we can no longer mint to ourselves. So also just for this demo, let's also set up account 2. Perfect. We set up account 2. Now, what we're going to do is we're going to pass in a recipient here. So who's going to be the one receiving the NFT? And the person that's going to sign it is, so the person who can sign this is the deployer of the Baby Jacob contract, which is account 0x01. So account 1 will sign this. It will get the public, we can say like recipient collection from the public path. And then it's going to say, well, then we need to borrow the Minter from account storage. So we saved the Minter to account storage here. And now we want to borrow it from account storage. So let's do let Minter equals signer.borrow a reference to baby Jacob.minter from /storage/NFT Minter. And if it doesn't exist here, we can panic. Say this path does not have a Minter. Okay. And then instead of saying let NFT equals baby Jacob.create NFT, we would say Minter.create NFT. And now all is good. So what we did was we borrow the recipient's collection, which is the person that we pass in. So we want to mint to like account 2, let's say. So we're going to borrow account 2's public collection. Then we're going to borrow the Minter from the signer, which has to be account 1 because no one else has the Minter, right? No one else has it since we just gave it to account 1 here. They deployed the contract. Then we use the Minter to create an NFT, and then we deposit to the recipient. So let's try this. So right now, no one should have anything, right? So account 2 should have nothing in their account, right? It's empty. But if we go to the mint and we say, let's pass in 2 to be the recipient, and then let's pass in 1 as the signer, it says, I minted an NFT to the collection. And if we go to get IDs now and check account 2, boom, account 2 now has an NFT in their storage. And again, if we try to run this from like account, like let's try to mint an NFT from account 3 or something, right? And let's try to deposit to themselves. Nope, doesn't work. Well, okay, well that's a bad example. Let's try this one. So it's not going to work because it says this path is not of a Minter. Or I guess it's probably more helpful. It says this account is not of a Minter, but you get the point, right? Because account 3 does not have access to the Minter. So that is how we safeguard the minting of our NFTs. All right. So there's only one more really confusing topic we have to go over today, and that is actually borrowing NFTs from our collection. So I know that this is a really hard lesson, but the good news is that you actually do know all of it. It's just that tying it all together is probably really tricky in your brain. But if you think about it, you actually know every single one of these steps. You know regular variables. You understand resources. You understand resource interfaces. You know, taking and removing resources from dictionaries. You understand like putting functions inside of resources. So a lot of this you actually know already. It's just that looking at it in one huge contract can be really, really daunting and really confusing. Um, the only new thing that I guess that you actually learned in today's lesson is this right here, which is the ability to save something to an account inside the contracts init function. But other than that, all of these pieces we've actually learned already, and I have no doubt that in time you'll be able to tie them all together. All right. So one last example here. Actually, what we can do also just to spice things up, let's give our NFTs a name. So inside of our NFT resource, let's just give it a name. That's a string. And we can pass in the string in the init function. So self.name name. And then down here, when we go to create NFT, let's just pass in a name to give the NFT. Pass it through. Right. So that allows us to read some cool stuff about our NFTs. So when we redeploy this, we can go to mint NFT, and now we have to pass in a name here. So we can pass in a name, and we can give our NFT a name. So that's all cool and all. So yeah, so now we're giving our NFT a name. Now the reason I'm doing this is because I want to show you what happens when we want to read information about our NFT. Right now, in order to read information about our NFT, we would have to call withdraw, print its name, and then deposit it back to our collection. Does anyone have any ideas? We've learned this in previous lessons about things we could use so that we don't have to withdraw it and then deposit it back to the collection. Is there anything that we could use to be helpful? Great job, Ashley. Exactly. So what we can do is we can add a function here called public function borrow NFT, and we can return a reference to the NFT like so. So what we can do is say return a reference to self.owned NFTs at the specific ID. So let's just pass in like an ID here, right? At the ID as, remember with references, you always have to put like a typecasting. So as a reference to NFT. All right, so let's refresh the page and we're all good. So this allows us to return a reference to one of the NFTs inside our collection here. So let's also make sure to put borrow NFT inside of our collection public, because this will allow the public now to read information about our NFTs, which we want, right? That's totally fine for us to do. All right. So if we redeploy this contract, boom, it's now deployed. We can set up some accounts. So let's set up account 1. Let's set up account 2. Okay. Let's mint someone an NFT. So let's just mint, I don't know, let's mint it to account 2. The name will be SWT. And we can mint it from the transaction here. So we have to sign this from account 1, right? Because they're the only person with the minter. So we send this transaction. It says I minted an NFT. And we can see that if we read account 2 now, they have one NFT inside of it that has an ID of 3. So we want to add another script here called read NFT, just like that. Okay. So inside of here, we can have a script that takes in an account to read the NFT from and an ID so that we can read a specific NFT's ID. And what we can do is we can return a reference to babyjacob.nft, right? Because this borrow NFT returns a reference to NFT. So we're just returning a reference to babyjacob.nft, right? Because we have to get it from the contract. Cool. So what we're gonna do is in this code we already have the code to get the public collection, and then we can just return collection.borrow NFT and pass in the ID. And that should return a reference to the NFT. So if we pass in account 2, and the ID they have was 3, execute, and look at, we get this huge log of stuff. We can see the UUID is 3, the ID is also 3, and the name is SWT. So that is an example of how to borrow an NFT and read its metadata from our collection. And that is the end of today's workshop. I believe that we covered everything we just finished chapter 4 now. Tough day today for sure. But the cool thing is that once you understand all of this, you'll actually be a pretty solid Cadence developer. And the even better news is that with Cadence, the learning curve is very steep at the beginning. But once you understand how to do like this NFT example, you'll pretty much understand how to do almost everything in Cadence. Because the NFT example sort of covers like a very broad range of topics in Cadence, like references, resources, admin stuff, collections. There's a lot of different things in here that's pretty helpful. Making sure I cover everything. Yep, should be good. Alrighty. That's the end of today's workshop. I hope that was helpful. And I will see you all probably next week. So next week is our last week. It is chapter 5. And chapter 5 is basically like I think the first 2 days are like minor, not minor, but like the first 2 days are things we need to learn in order to finish the contract. And then on Friday next week we will finish the NFT contract, and that will be the end of the boot camp. Thanks everybody, and have a fantastic weekend. SMUT, enjoy your concert. I really hope you enjoy it. Snowmobiles, get some rest. You too, Ashley. And thanks everybody. And I'll see you next week on Wednesday. And also look forward to Float being on mainnet in the next few days. Oh yes, Minecraft. So if any of you are going to Minecraft tomorrow, I'll see you there. The big Minecraft event. I hope to see you there. Yeah. See everybody. Bye bye. Oh, I forgot to end the stream. I started playing Minecraft.